Alright, so we're going to wrap up what we're doing with Chapter 7 today. And so we're looking at 7.3, multivariate, linear systems, and row operations. So if you don't have your calculator handy, you're going to need it. Go ahead and grab it. And so basically, there's a whole bunch of theorems and a whole bunch of notes, definitions, whatever here. I'm just going to give you a quick little rundown of a couple of these things, and then just going to show you some examples on how to do them on your calculator, and that's kind of going to be it. So, we're dealing with some different kinds of elimination here, and this is stuff that if you were to go on and be a math major, possibly an engineer, you have to do this by hand, but I'm going to let you, or most likely they will require you to be able to do it by hand, but I'm going to just do it on a calculator for you, because if you don't go that route, this will be the one and only time that you need this, with the exception of maybe some in calculus. So, we have a couple definitions here, or just like words that we need to be familiar with, so let me put those up here. Basically, we have an augmented matrix, which essentially is just a matrix that comes from a system of equations, just to put it, simply. And by this I mean something like, if you have x squared minus 2y plus z is equal to 7, and I don't know why I said x squared, 3x plus 5y minus 2z is equal to 4, and 4x minus 3y plus 3z is equal to 2. Okay, the matrix that comes out of that would just be, it comes across and just with the numbers that are in front, 1, negative 2, 1, 7, 3, 5, negative 2, 4, 4, negative 3, 3, and 2. And often there will be a dotted line between the coefficients and the answers, okay, or the solutions here. Okay, this will all make sense in a minute once we actually start doing problems with why we set it up this way. Because we're actually going to solve these systems using your calculator rather than the method you used to use, which was by hand. Just this portion here would be the coefficient matrix. Okay, if it was to say something about that. Okay, so then there's two different forms that we need to be aware of, and so I'm going to give you the kind of rundown of those really quick, and then we'll just jump into some problems. So, row echelon form of a matrix. Okay. A matrix is in row echelon form if the following conditions are satisfied. One, rows consisting entirely of zeros. Okay, so like a row, okay, across, row across, consisting entirely of zeros. Okay, if there are any, they're not always going to be one. Occur at the bottom of the matrix. Okay, so it would have to be here at the bottom. 2, the first entry in any row with non-zero entries is 1. Okay, this will make, again, more sense once we actually do these on our calculator and you see what I'm talking about. And then lastly, the column subscript, if I can spell, of the leading 1 entries increases as the row subscript increases. Alright, so that's row echelon form. Not to be confused with this next one. Maybe, if I can find what I want to say about it. Okay, row reduced echelon form. Okay, it basically would look something like this, 1, 0, 0. Okay, and it's going to have some number over here. Okay, so this can be any non-zero number over here. Well, it could be 0. We'll just say 3. 0, 1, 0. 2, 0, 0, 1, 5. Okay, so then these would be your solutions here, and this is in row reduced echelon form. Not saying there couldn't be a row of zeros, but that is how we would set that up, or what that would look like. Okay, but otherwise it kind of follows the same principle here with the row echelon form. So just, I guess to make you aware, in case any of you do happen to go on to be math majors, elementary row operations, which these are what you're going to be doing, or what your calculator is going to be doing that you could do by hand, okay, to get to these two forms here. But a combination of the following operations will transform a matrix to a row echelon form. So different options are to interchange any 2 rows, so you can just swap them. Multiply all elements of a row by a non-zero real number. Okay, that could even be like a fraction. Okay, that's simply all it means is it can't be 0. And lastly, you can add a multiple of 1 row to any other row. Okay, so like I said, all this is done on a calculator for us. So we're just going to go ahead and type that up and go from there. Alright, so most of these problems here are fair game, but we're just going to start and work our way through, okay, because pretty much all these we're going to be, well, yes, all of these we will be doing on our calculator. So let's see. So something like number 2, it says to use substitution, but we're going to go ahead and do it on our calculator. So we have 3x minus y plus 2z is equal to negative 2. We have y plus 3z is equal to 3, and we have 2z is equal to 4. Now, this one would be very easy. Okay, z is equal to 2, plug in 2, that gives you 6. Y is equal to negative 3, plug in 2 and negative 3, and you can solve for x. Piece of cake. Okay, and quite frankly, for this problem, that may be faster. But I do want to show you how to set these up as an augmented matrix. Okay, that's what we're looking for here. So you're going to set this up. Okay, and like I said, you do the dotted line here to show where the solutions are, and then now we're going to go through and fill this in. So you read across, okay, if something isn't there, it gets a 0. Okay, so in this top one, everything's there, so x is 3, y is negative 1, z is 2, and then the solution is negative 2. I have no x's, so I get a 0. I have 1y, I have 3z is equal to 3. I have no x's, no y's, but I have 2 z's, and that's equal to 4. So now you're going to type this in your calculator, so you're going to need a 3x4 matrix. Trying to get the lighting so you can see it. Alright, so you're still going to second matrix, edit, and pretty much all these are going to end up being a 3x4. Alright, so you're just going to type these numbers in order. So 3, negative 1, 2, negative 2, 0, 1, 3, 3, 0, 0, 2, 4. Second quit. And now you're going to go to second matrix, and you're going to go to math, okay? Now, we're going to use RREF, okay? It's letter B for me. I'm assuming it is for you, but RREF, okay? That means row reduced echelon form. So let me make a note of that here. So the way you would show me that you're doing this on your calculator, okay, the way you would show your work, first of all, you'd write this matrix up, okay, and then you would write on your paper RREF of matrix, and then you would just tell me whatever letter matrix you put it in, okay? So, here we go. If I can get lighting, there we go. Alright, so I'm RREF, and then second matrix, I put it in matrix A. So RREF of matrix A. So this is how you would write this. So then you would come over here and you would write down the matrix out of your calculator. So it's 1, 0, 0, negative 3. I'm going to go ahead and do the dotted line. 0, 1, 0, negative 3, and 0, 0, 1, 2. Now, wherever the 1 lines up, that means that that's what that variable is equal to. So x is equal to negative 3, y is equal to negative 3, and z is equal to 2, which we could look up here and we could verify. Okay, but remember your answers are written as an ordered pair, so it'd be negative 3, 2. Okay, so when you do your work, what I'm looking for, first of all, I'm looking for this. Okay, I'm going to be looking for these 3 things. I'm going to be looking for you to show me this RREF. I'm going to be looking for you to show me what your calculator gave you, and then your final answer here written in the form of an ordered pair. Okay? So that is what I'm looking for here with these types of problems where you're solving equations. Okay, if you're not actually solving equations, you don't have to necessarily show all of these steps, and I'll show you what I mean here in just a minute. Alright, the next thing says to use Gaussian elimination to solve the system of equations. That works the same way. Let me set up one of these for you. Okay, and it could end up with, like, you could end up with 4 things as well. Okay, you could have X, Y, Z, and W. if that happens, just leave it as a matrix. Don't rewrite it as an ordered pair because it'd be kind of weird. This is technically an ordered triple. I shouldn't be saying ordered pair. So, number 6, x plus y minus 3z is equal to -1. 2x minus 3y plus z is equal to 4. 3x minus 7y plus 5z is equal to 4. Alright, so the first thing I do is I'm going to rewrite it as a matrix. Alright, so these I'm not missing anything, so I'm just going to read the numbers straight across and pay attention to the fact that I do read the signs with them. So it's going to be 1, 1, -3, -1, 2, -3, 1, 4, and 3, -7, 5, 4. Okay, so that's part 1. Now part 2 is going to be RREF of, I'm going to put it in matrix A again. So second matrix, I'm going to go edit matrix A and put these numbers in. Oops. 1, 1, -3, -1, 2, -3, 1, 4, 3, -7, 5, 4. And then second matrix, edit, or sorry, not edit, math, up arrow to RREF. And then second matrix A. Alright, so these ones are kind of weird, okay, in how their answers come out, because obviously you notice there's this like 1.6 and this 1.4 over there, which in theory we shouldn't have, right, when we do our RREF, but it's not necessarily that something is wrong. For sure, okay, but in this case, okay, if you end up with something like this, because when we row reduce echelon form, okay, we should have a 1, 1, 1, and everything else should be zeros except for our answers. This is going to be a clue to you here, okay, that it is no solution. Okay, so if you don't end up with it in the right form, so I had 1, 0, -1.6, 0, 0, 1, -1.4, 0, 0, 0, 0, 1. Okay, that means there's no solution because it did not row reduce all the way, but there's nothing that can be done to finish row reducing it. Okay, so there is no solution to this particular problem. Let's see. Which one do we want to look at next? Let's see. All right, 17 through 20, it just wants a row echelon form. Which on your calculator is going to show up as just REF, okay, for row echelon form. So we're going to do, let's do 18. 1, 2, -3, -3, -6, 10, -2, -4, 7. Okay, so now you go to your calculator. So second matrix, over to edit. It doesn't matter which one I do it in. 3 by 3 for this one. So 1, 2, -3, -3, -6, 10, -2, -4, 7. So you can quit second matrix, go to math, and now you're looking for REF, okay? So REF here, row echelon form, not RREF. We're looking for REF, okay, and it will give you a different answer in second matrix A. So now, okay, and you still are going to get a 3 by 3. It's just making that repeat all the way. And this follows the rules, okay? We can only have zeros at the bottom. Anything that's non-zero has to be a 1, okay? And so this is a 1 followed by numbers, and that's okay as well. So basically, when you write your answer here, you would just show me that you did REF of matrix A. And then you would tell me what that's equal to, which would be 1, 2, -3.3, and then just do the repeating bar, 0, 0, 1, and then 0, 0, 0, just like that. And that's all you'd have to show me for that type. Let's see. Finding the row reduced echelon form, let's do 22. It's kind of a big one, so just to see what that looks like. So 22, we're back to RREF. Okay, so it is 1, -2, 2, 1, 1, 3, -5, 6, 3, -1, -2, 4, -3, -2, 5, 3, -5, 6, 4, -3. Okay, because this one is so big, I'm just going to write the RREF out front here. Okay, and that's fine. You don't, like when you're copying these problems down, you can just write it this way as well, just RREF of that. So then I'm going to go to my matrix and I'm going to plug everything in. So now I have a 1, 2, 3, 4 by 1, 2, 3, 4, 5. So I'm going to have a 4 by 5. 1, -2, 2, 1, 1, 3, -5, 6, 3, -1, -2, 4, -3, -2, 5, 3, -5, 6, 4, -3. And hopefully I typed that in right. Alright, so then second matrix, we're looking back for the RREF. Second matrix A. And notice I have the ones on the diagonal and numbers down the side. So with this one, okay, this one wasn't a system of equations. It didn't tell us anything about it. So I would write then my answer as 1, 0, 0, 0, -19, 0, 1, 0, 0, -4, 0, 0, 1, 0, 7, and 0, 0, 0, 1, -2. And that would be all you have to do for that one. Alright, and then the next set of problems, okay, we're almost done, I promise, says to write the augmented matrix, okay, for the corresponding equation. So write the augmented matrix. So here, okay, something like 28, 3x minus 2y is equal to 5, negative x plus 5y is equal to 7. Okay, so all I would have to do is come over here and write this 3, -2, 5, -1, 5, 7, and that's all I'd have to do for that problem. Okay, then if I wanted to go in the reverse, okay, so the reverse of that, if I'm given something like 32 where I have 2, 1, negative 2, 4, negative 3, 0, 2, negative 1. All I have to do here is just go across 2x plus y minus 2z is equal to 4. Negative 3x plus 2z is equal to negative 1, and that's all I would have to show for that. Sometimes I leave a gap just for that, but you technically, if it's a 0, you don't even have to write anything there. And then lastly, it wants you to find the row-reduced echelon form of the system of equations, okay, at the last section. So I'm just going to do one more of those, and then we'll be done. Number 40 is, let's see, x plus 2y minus 3z is equal to 1. And negative 3x minus 5y plus 8z is equal to negative 29. So here I need to go through and row reduce this, but I need to set it up as a matrix first. So I will go through and get ready to do that here. Just checking on one thing really quick. Checking an answer here, okay. Alright, so I'm going to set this up. 1, 2, negative 3, 1, negative 3, negative 5, 8, negative 29. So now I have a 2 by 4. Second matrix, edit, 2 by 4. 1, 2, negative 3, 1, negative 3, negative 5, 8, negative 29. Second matrix, RREF. Second matrix A. Now, this doesn't look like it's row reduced necessarily, okay, but this does not mean that it is, or that it doesn't have a solution, okay, in this case. And so all we have to do here then is when we go to rewrite it, so I'm going to obviously write down this ordered pair here, or sorry, this matrix, get my words straight. We're going to write down this matrix, but then what we're going to do is we're going to say what, basically, because of how this is written, we have to write things in terms of z's. Okay? So, we write this matrix down here that we just got. So, after doing RREF of the matrix, I get 1, 0, negative 1, 53, 0, 1, negative 1, and negative 26. Now, when I go to write this, I don't just say x is 53 and y is negative 26. That's not true because of these negative 1s here. So what we do is we say that x is z plus 53. Say that y is z minus 26. And then this is just z. So we don't know what z is, but we know that if there were to be something, this is what it would be. Okay, or that's how we would find z. So based on what z is, we can use that to find x and y. Alright, and that is true for a couple of these, like this, and the same thing if you have like a w or something like that. So let me go through and pick some problems for you guys. And if you have questions, I know this is kind of a lot of stuff. I mean, most of it is on your calculator, but it's just like being able to set it up and stuff like this kind of a deal here. So, let's see. Also trying to look because the answers are on a different page. I'm going to try to make sure I give you guys problems that actually have, mostly have solutions and stuff. 1, 3, $17, $19, $21, $25, $29, $35, $39, I think that's good. Okay, 39 here is one that will look like number 40. Okay, but other than that, I think you guys should be able to do those. So it's good. If you have any questions, let me know. I know there was a question from something from like 7.1, so I will get to answering that, I promise, before your quiz. And I'll also send out some review problems for you guys to do as well when I post this. So have a great day and enjoy your last, 6 days of school, 7 days of school?